it really is a great pleasure now for me to introduce Charles Goldman. This has become something of a routine now, not a routine. What's the word I'm looking for? It's a tradition. It's a tradition. It's a special event. And I used to joke 6 or 7 years ago and say, well, this may be the last time we have Charles here. And say, well, this may be the last time we have Charles here. But he keeps coming back.
You never know.
And it's fantastic because really, we wouldn't be here, you wouldn't be here, the lake that you know wouldn't be here if it hadn't been for what he started 40 or 50 years ago. Part of it was the science. I mean, science was done, measurements were taken. We actually have a record of the lake, what the lake was like 50 years ago. But a large part of it was just the advocacy, trying to make the case. And this, cast your minds back. Those of you whose minds were here then, 40 and 50 years ago, this was the front. People were making money. This was exciting. And for somebody to stand up and say, not so fast, we may be losing something special, took a lot of courage. So he's continued from those days to the present. He hasn't slowed down at all. His latest, what would you call it? I think let's call it a crusade, because I know he's really worried about the impacts of climate change, our drinking water, not just at Tahoe, not just in Nevada and California, but worldwide. So this evening he's here, he's going to talk about climate change and the world water crisis. Dr. Charles Goldman.
Well, I wrote a long speech, but I think maybe I can add about it. It's a great pleasure to be here, and I want to particularly thank the docents who stayed on to hear me, and of course Heather and Jeff who invited me, and also my wife Nancy, who's put up with me all these years and continues to keep up with this kind of non-retirement retirement. Some of you may remember me in times past, but I've grown this beard to look my age finally, and if you keep moving, the Grim Reaper may not catch up with you so rapidly. So staying in motion, I think, is my main plan while we try to save at least one lake at a time. Nancy and I were in Mongolia last summer, working on a lake, Havasu, that's incredibly similar to Lake Tahoe, and is threatened just the same way Tahoe was back in the late 50s and early 60s when I first arrived in the basin, in a bassinet, of course. But since then I've tried to grow up, and it's difficult, you know. There's a lot of pressure to kind of stay young, so I worked 52 years for the University of California, and then retired and really got active. And today I want to talk to you about something that in many ways I'll be preaching to the choir here, I've got to admit that. But I don't think it's ever too late to remind people that climate change is probably the greatest threat to humanity since the advent of the atomic bomb. I mean, it is really, really serious. I have half a dozen students around the world that are working on various aspects of it. We got them all together to write chapters for a book on the subject entitled Climate Change and Global Warming on Inland Waters. It's on brief commercial here. It's available on Amazon. Wiley Blackwell actually published it. And finding my clicker here, I will proceed. The climate change is occurring so fast that the models that they're making can hardly keep up with it. One of the latest discoveries was that this major West Antarctic ice sheet is being undermined, and there doesn't seem any way of saving it, and it's going to commit a tremendous amount of additional water to the world's oceans. And when we consider the large number of people living on the coast, we have a serious future problem if we don't really begin to take some pretty dramatic efforts. My other concern is the enormous amount of disinformation that's being used. It's pretty clever. It's exactly the same way the tobacco industry proceeded when they tried to convince everybody that smoking really was good for you. And climate change is not going to be good for many people. In the short term, some places will enjoy warming that maybe will be beneficial. Flooding is going to be a major problem, as it was in the Midwest. So you could hardly plant the corn in Iowa this year because of flooding. And when you consider that countries that have shallow coastlines, with a lot of people depending upon the agriculture, we have to face the fact that climate change is going to affect the whole world in a variety of fashions, and most of them negative. Just small things that have just come up that I pop off the web. The puffins are dying off simply because the fish that they're now trying to feed their young can't be swallowed by the puffins. And there's been a dramatic change in the small fish available for the puffins, so they're now forced with feeding a fatter fish that the youngsters can't swallow and simply die of starvation. Just a strange, one of the many impacts that climate change is bringing on the marine world. So we have heat and floods. The New York Times has recently covered a number of the problems facing climate change. At the same time, there's a major attack on science now. People are willing to believe science when it benefits their interest, but when it goes against, selling all the oil we've got in the ground, they manage to spend millions and millions of dollars creating disinformation. And a good example, the Koch brothers, who do a lot of good things. They've built a lot of, supported the arts, made a lot of good buildings, supported science and so on, are spending fortunes now in defeating candidates who even mention climate change as a possibility. And this very effective disinformation program really affects a major portion of our population. There's so much attention to television. I remember a campaign years ago when one of our local individuals was running for governor, and when the gubernatorial primaries were over, they came out in votes exactly in proportion to the amount of money they spent on television. And so it's kind of an uphill battle fighting this. Some of you saw that in the flyer advertising this talk that Harry Reid was kind of peeking out of the corner at me, and we both had kind of a disturbed look on our face. Well, Harry's really struggling against climate change deniers and the attack on science. And finally, Obama's come out as well. If we look at U.S. climate change, we find where the heat and floods have occurred. The red spots are plus 2 degrees. or more around our United States. Another interesting article on the web was the end of snow. Tahoe, for instance, has a major investment in the ski industry, and you can only make snow if it gets cold enough, and we certainly didn't get the snow this year. In Russia, of course, they made a lot of snow and blanketed large amounts of snow so they could actually pull off the Winter Olympics. But that's going to be more and more difficult. A lot of people argued about carbon dioxide and the increase over the years, but it matches so well with the global climatic change that even some of the severe doubters, like Professor Mueller at Berkeley, have changed their minds, probably influenced by a lot of student pressure. The youngsters aren't fooled by the disinformation. But if we look at the rate of change, which is a really frightening aspect of this, we see that emissions were increasing at about 1% per year in 1990, but by 2000 to 2008, they were increasing at 34%. And this is the line we probably could have lived with, but this is the line the way it's changing, and this is the current projection, which is totally frightening. We just hit 400 parts per million of CO2 in the atmosphere, a level never before recorded. We're able to go back and look at the ice sheets, do paleolimnology, and determine that there's never been a rate of change compared with this in recorded history, even though we've come in and out of glacial periods. One of the most alarming elements from the standpoint of fresh water is that there is a major shortage of fresh water developing globally. Who would have believed a decade ago that we'd all be walking around with plastic bottles of water? And of course, there's a good campaign in Tahoe to drink tap water, which I consider the Avion of drinking water.
Yes.
Really personalized. So let's take a look here. There is some scientists make mistakes, and there was a professor at the University of Colorado who was using satellite imagery and said, you know, the glaciers in the Himalayas aren't retreating, they're actually expanding. And why did he come up with this conclusion? Because the satellite imagery didn't distinguish between water and ice. And what they were seeing was this increasing water discharge, bringing up the water levels and expansion of the appearance of the glaciers, which was just a mistake, an illusion. This is one I stole from Jeff Schlotto. Jeff, I notice, is always ahead of me in these PowerPoint presentations. I need to intern with Jeff to catch up with really proper PowerPoint production. But you can see Bhutan, Nepal, all the way up into the Indus. This area feeds the 7 mightiest rivers in Asia. And as the glaciers melt, they're supplying water now. But what's going to happen when the glaciers are gone? The food supplies are going to be reduced in a really frightening way. One of my former students, Katie Walter, a UNR student who came to Davis for her master's degree and actually did her thesis on the Tahoe Keys, then went to the University of Alaska, did her doctoral thesis in Russian Siberia on these frozen lakes. And here you cut a hole through a frozen Alaskan or a Siberian lake, and out comes enough methane that you can light a fire that would go higher than the ceiling. And methane is about 22 times as potent a greenhouse gas, providing this blanket over the Earth's surface, which prevents the back radiation. And that's why, as you'll see later, the nighttime temperatures have increased appreciably at Tahoe, but not the daytime temperatures. The daytime temperatures fluctuate a lot, but the nighttime temperatures have really shown a steady increase. Now, if I can make this play,
I can do it.
doesn't have a cursor.
I can do it. Hang on.
This is really an interesting slide because, here we go. This is starting in the former 1800s and showing how temperatures have globally increased from 1880 to 2011. And it's a pretty frightening scenario as all of these temperature records are combined to look at the global scene. And it is really getting warmer. Another one that needs a cursor on it is the distribution of summer anomalies. And here's the way the anomalies are shifting as we go through the years. They're just getting warmer and warmer. We're getting records broken everywhere in terms of the heat. Another thing to keep in mind, and we have one New Zealand representative here, Todd, is that about the only place in the world that we've found no temperature impact on the lakes is in New Zealand. And since it's surrounded, big island, North Island for instance, surrounded by cold water, it's not too surprising that this is the one area that hasn't shown a significant increase in lake temperatures over the last 30 years. This is a representation of melting just between July 8 and July 12 of 2012, which was a rather warm year. The reflection from snow cover on Greenland, and then a few days later, it's all turned to meltwater. Some of the attacks on climate change have focused on the idea that we do go in and out of glacial periods, and we do also get different solar radiation. But notice that while one of the most intensive warming periods has occurred from 2005 to 2011, this occurred during the lowest solar radiation. So that argument is totally fallacious. Solar radiation, even when it's been reduced, still has supported the intensity of temperature changes globally. The planet is warming. This is another show of the breakup of polar ice, and there's a video to go with that one, showing the breakup here. This is work of Derek Mueller of Trent University, a time lapse of breakup. And of course, some interest has been developed in the Arctic on the plight of the polar bears, and one of my best-known students, Warwick Vincent at Laval University in near Montreal, was on an icebreaker and took this actual picture of the polar bear crossing. It was kind of neat. But if we look at this slide that covers the period from about 1997, 2010, 2007, 2010, 2011, we can see that the extent of the ice has just decreased dramatically every year. This is the 2011 extent of the Arctic ice pack. And why is the Arctic ice pack so important to us? Because that enormous chunk of snow and ice reflects heat back into the atmosphere. And once we lose that, where does that heat go? It goes into the ocean. It alters the flow. Some of the scientists at Woods Hole predict that if this becomes extreme enough, that the Gulf Stream might lose its own. And if the Gulf Stream shuts down, Europe's going to freeze. So we have multiple impacts of climatic change, some of which are predictable and some of which are only guessed at. White areas are in the polar region of 10 years or greater show the decline from 1980 to 2007. Just lots and lots less permanent ice. Now this is another recent shot. They have this remote observatory on the North Pole that takes a panoramic picture around it. And this is what happened last year. It actually got wet. And as soon as you cover a surface with water, you lose the albedo, you begin to absorb more and more heat. So this is kind of an autocatalytic reaction. What about the tundra? Permafrost used to extend a lot further south than it does now. With global warming, it's retreating. And as it retreats, you're exposing all of this organic carbon material, which the bacteria get working on, and out comes methane. 22 times as potent a greenhouse gas as carbon dioxide. So these are autocatalytic reactions that are feeding on each other, and we've got to get to work really soon if we're going to make a difference against it. Little bit of humor here. I think that says something about the Golden Glacier and discovering that I discovered that I invented the internet or something like that. And they're having a whiskey at the Golden Glacier. It's kind of a cold honor when you get right down to the glacier. But I've been really concerned about it. And the latest report is that it's not measurably retreated. And of course, the Antarctic can actually acquire more snow as the oceans warm, evaporation increases, and that can squeeze more glacial material into the ocean. This is an interesting case. Professor Mueller was a very strong denier of climate change and global warming. And I suspect his students really got after him because suddenly he confesses that he not only agrees that carbon dioxide makes the best match with warming, but he even goes a step further and indicates that maybe humans are almost entirely the cause. Well, this was great until you read the article that followed on Shame on You, New York Times. Did any of you see that article? It's pretty interesting because by making this statement, it provided him with a new platform to add further confusion to what is obvious to 95, 8, 9% of the world scientists that climate change is occurring and is a really serious problem. Even Obama has finally shown some fairly aggressive action on climate change and making it maybe the main thing that he'll be remembered for after his period of presidency ends. And again, a commercial on our book, Climate Change and Global Warming of Inland Waters. Won't force you to read all of this, but because it's mainly covered in the talk. But it does encompass everything from the Arctic to the Antarctic, warm water systems, tropical, subtropical, and Arctic. And of course, it was edited by three of us: Michio Kumagai, a leading Japanese limnologist, and Richard Robards from Canada. Now, it's a good idea to not blame everything on climate change and global warming. And a really good example is the Sea of Aral. Some of you may have followed the Sea of Aral in National Geographic. It used to support 16,000 fishermen and factory workers who handled the fish canning around this enormously productive lake. When Stalin decided that he'd get into the cotton business and diverted the main inflows of the Sea of Aral for agriculture. And by cutting off this, if we look at by 1997, the lake had actually been essentially split into two parts, and this exposure of the littoral zone of the lake, very fine material, blows up in the wind, causes major respiratory problems, and we can pick it up all the way to the Arctic Circle. And now, if we look on the Sea of Aral, it is no longer really there. And unless there's a major change to the east in the water supply, it'll never be brought back. It'll be a Bonneville salt plant from now on, where the wind picks this dust up and distributes it globally. I got started when I came out from the Midwest, where lakes were suffering severe eutrophication. Came around the corner and spotted Lake Tahoe, and I thought, my God, this is just like the lakes I worked on in Alaska that were essentially in wonderful condition. And I realized with the development that something had to be done to slow down the nutrient input into the system. Certainly, my greatest success was with a group of civil engineers from Berkeley, McGahee, and Pearson, Kaufman from Stanford, and Rowley from the University of Wisconsin, who were brought out on a special grant from the Flashman Foundation to investigate what might be done with Lake Tahoe. And one of the ideas that was foremost was engineering, sanitary engineering had progressed so far that you can make drinking water essentially out of sewage water. So they wanted to use advanced wastewater treatment at South Tahoe to keep Tahoe clean. Well, I had perfected a bioassay technology utilizing carbon-14 in Alaska that just fit perfectly. I was able to take the tertiary effluent from the plant, add it to mid-lake water, and turn it green in 3 days. Although the tertiary system at the time was extremely good at removing heavy metals and phosphorus, the ammonia went right through. And when they exported the effluent to Indian Creek Reservoir, which is now used for really good subalpine irrigation over along the Carson River, they found that the lake had so much ammonium hydroxide in it that it killed the trout every spring, kind of on a regular basis. Once the pH gets fairly high and the ammonia goes into ammonium hydroxide, it's extremely toxic. Well, this is extreme eutrophication, the kind of thing we want to avoid, but there are lots of hyper-eutrophic lakes in the world. One of the most telling elements of my research, which really got started in 1959, and then we didn't have any money up until 67, and I was mainly concentrating then on Castle Lake, which has been kind of a control for Tahoe. It fluctuates the primary productivity. This is a very sensitive measure of algal growth rate, how much carbon they take up per unit of time. And Tahoe was so ultra-oligotrophic, low fertility, to which we owe its blueness, that this method of carbon-14 was the only method sensitive enough to measure change. There wasn't enough chlorophyll, there wasn't enough oxygen change, so this was the method of choice, and we've kept it going over these many years. And of course, it has been in careful agreement with the decline in transparency. And I think if we did one thing right with the population in the basin in general, and now the world as a whole, we kept it simple. People understand keeping Tahoe blue. And our data through the League to Save Lake Tahoe was certainly instrumental in changing people's ideas about Tahoe and recognizing the fact that if Tahoe went downhill, everybody loses. Real estate properties go down, vacations here decrease, the gamblers down on the south end don't have as many clients. It really is a combination of not only aesthetics but of economics as well. And people who see Tahoe, many say this is the most beautiful big lake in the world. And I always felt really lucky to have settled down at Davis for 52 years to work on it. And now having Dr. Slotto and a wonderful group of docents educating the population. When I first reported that there was smog in the Tahoe Basin, I was identified in the local press as a tree-huggy environmental fanatic. And all I was doing was reporting on the lead levels in Harrah's parking lot when those buses come in. And it was quite similar to Los Angeles. I mean, those were the facts. And they've been held up over the years by the work of a distinguished physicist from Davis, Tom Cahill, who actually fingerprinted the air pollution in the basin and determined that it was in-basin created. And of course, it doesn't, not hard to believe if you're here on the 4th of July and you see automobiles all the way around. I always hoped we'd get a monorail or something, but that's one of the areas that have failed in so far. Atmospheric deposition turns out to be incredibly important. This is deposition of the top of total nitrogen, total phosphorus, and total nitrogen to phosphorus ratio in comparison to the stream runoff. And it actually is greater than the stream runoff. So the sky is actually falling. And what has occurred over the years is the lake has made a dramatic change from a western lake, which tends to be nitrogen limited, algal photosynthesis driven by how much nitrogen is available to the algae, to a lake that's highly phosphorus sensitive. When I got here, the ratio of nitrogen to phosphorus was essentially 1-to-1. It's now close to 40-to-1. So we've accumulated so much nitrogen from atmospheric fallout, NOx from vehicle exhaust, ammonia from agriculture. We were fortunate in getting the cattle out of the basin. Bob Harris, who some of you may remember, managed to do that while he was the local supervisor of the Tahoe National Forest. We really miss him. One of my, in fact, my last graduate student, Jason Snyder, who did his PhD with me and got a lot of help from Tom Cahill, a physicist I mentioned, was able to track dust from the Gobi Desert in China all the way across Korea, Japan, all the way across the Pacific to Lake Tahoe and identify its fallout here. Now this makes, I think, a really important point. The world should recognize that air pollution is a global problem. It's not just a local problem. What they do in India, what they do in China, what we do here in North America affects everybody. And I kind of hope that this idea would pull people closer together to work with the global environmental problem that, if anything proves it, atmospheric deposition does. Lake Baikal, the oldest, deepest lake in the world. I've made 8 expeditions to Baikal with members of the Tahoe Research Group over the years, and it is a totally amazing lake. It's got to be Russia's blue gold in the sense that it contains 20% of the Earth's unfrozen fresh water. To put it in comparison with Tahoe, just one little embayment, Verdansk Bay in Lake Baikal, is just the size of Tahoe. If you started at the south end of Baikal and went to the north end, it's like going from here to Los Angeles. It is one big lake. In fact, it contains, as I said, 20% of the Earth's unfrozen fresh water. And if you don't believe in evolution, how can you explain the fact that it's got 2,500 plus endemic species found nowhere else in the world that have evolved in this lake, including a freshwater seal that keeps a hole open during the wintertime. And they've used it for years as a north-south highway. During the war with Japan, they actually ran the Trans-Siberian Railway across it so it didn't have to go around the end of the lake. And I think the last locomotive went down. And of course, Putin was hoping he'd find the white Russian gold that supposedly was lost crossing the lake too, but I guess he didn't. That's the Bearshagen out there. It's a 650-ton research boat, and in my youthful exuberance, I agreed, or I was challenged by the captain of the ship, who had had a lot of vodka, to dive off the top of that into the water. And the tears were running all the way back. I swear I was at terminal velocity when I hit the water. And that was my last really high dive. But, well, there's a whole lot of story to go with the Russians. They sure like their vodka. You were expected to drink with them too, and another story, another time. I have a problem if I take too many sidebars, I never get back on track. This is the Lake Baikal cellulose plant, and you can follow this atmospheric pollution 50 kilometers down lake. Fortunately, the pollution that it discharges into the south basin of Tahoe, of Baikal, flows out through the Angara River, so that the middle and north basins of the lake are extremely pristine, and there's been very little development to date around this Siberian lake, which borders right on Mongolia. And the Buryats are the native tribe that occupy the Mongolian side of Baikal, have a really religious attitude about the lake, including pouring a little vodka into it to keep the lake spirits happy. But an interesting comparison of Tahoe with Baikal is that if you poured Tahoe over the state of Texas, you'd cover them up to boot depth, about 8 inches. If you poured Baikal over the state of Texas, you'd cover it to 98 feet.
Wow.
124,000 cubic kilometers of water. 20% of the Earth's unfrozen fresh water. Certainly Russia's greatest single natural resource. And now we come to our favorite lake, Lake Tahoe, which is in limnological terms, and we've always been cursed with the fact that nobody's ever heard of limnology. I mean, you tell somebody you're a limnologist, and 99.9% of the time they give you a blank look, and then you try to figure out how to explain it to them quickly, and you say, well, we're inland oceanographers, and they kind of get it. But it's a Greek word, limnos, which means lake or marsh, and as a result, there aren't too many Greek scholars about these days, although the new chancellor of the University of California knows Greek, is Greek, and has finally decided to hire a replacement for me. So that's the good news. Okay, we're dealing with a lot of limnology. A lithotrophic lake, very low in fertility, a lot of transparency, no big problems, and you can usually drink it. Mesotrophic lakes tend to be a little more productive, and this is Castle Lake, California, which actually doesn't have that little gap in data in the early 60s that we had at Tahoe, because I got a grant to study this lake first, and I kind of kept Tahoe going on the side with the National Science Foundation grant. The first lake in the world to be discovered to be trace element limited. In other words, the fertility of this lake was controlled by a shortage of molybdenum. You add molybdenum to the lake, the productivity jumps, fish production jumped about 5 pounds per acre, and we were able in those days to do a salt shaker application of molybdenum to the lake and follow the impact, which was an increase in all levels of the food chain. I've often thought that lake management might eventually take trace elements more seriously into consideration. Found lots of lakes in New Zealand, for instance, that are trace element limited. Lake Biwa, the largest lake in Japan, actually supplies water for 14 million people. And this lake is becoming increasingly warm and increasingly eutrophic. And the more eutrophic a lake becomes, the more expensive it is to treat the water. And this is a star student, Hans Pearl, North Carolina State, which incidentally, there is now a limnologist that is president of the university. And it's Carol Fold. She did her PhD thesis on Lake Tahoe at UC Davis, and was the provost at Dartmouth, and is now the president of North Carolina.
Nice.
And that's pretty amazing. There hasn't been a president of a university that was a limnologist since Virgin Judea near the turn of the century at Wisconsin. And so a few people are learning what limnology is. Hans has been working at Lake Tahoe in China. It's hyper-eutrophic. Actually, the way Clear Lake was in California when I first got here, the first time I saw Clear Lake, I thought it was a golf course. I came around the corner there, the route that goes by the casino now, and the ducks were actually walking on top of the algae pile up near shore. And there wasn't a breath of wind, so it was just flat. And I thought, my God, the biggest green I've ever seen in my life. One of the things that goes back to the population bomb of Aral Lake from Stanford is this tie, this inseparable tie between water and agriculture and food and population. These are so tightly linked. When we look at pictures like India, the river people, the fact that the population just hit 7 billion only 10 years after it was at 6. Global average water consumption is only 1,240 cubic meters. Cubic meters, a lot of water per year. The Chinese are almost half of that, and we, of course, are about twice that much in North America. And so water conservation is increasingly important. I heard a speech by Representative John Garamendi at a fundraiser in Davis a few months ago, and he pointed out very enthusiastically that any conserved water is like new water for Los Angeles, you know. And I'm beginning to think that maybe we're not going to be able to support lawns the way we have at Tahoe, and certainly in the drier areas of the state, we may need to go more into low water vegetation, and I think that may well be one of the big conservation moves of the future. The scary thing is that the demographers indicate that we could have 14 billion people by mid-century, and that is unsustainable in terms of food supply. So climate change, availability of decent drinking water is increasing as a global problem. We're trying to deal with it through the World Water and Climate Foundation, headed up in Canada now by Richard Robards. But entrepreneurial funding is getting increasingly difficult during any economic downturn. So it's hard to know how that's going to go. But here's this population. I came all the way back from Baikal to attend the population bomb meeting in Chicago with Aral, and it was ahead of its time, literally. Why didn't it happen? It's ticking, the bomb's ticking, but it didn't go off. 2 reasons. Increased agricultural production in India, the Green Revolution as it was called, and the draconian population control enforced in China. And it seemed pretty brutal, but there would have been really mass starvation in China. And it's, of course, an enormous threat to China now, and it's why they're using the dollars that we spend on everything the Chinese make is now being used to buy up land in Africa, buy up resources wherever they're for sale. And the leaders in China really recognize that they have a population bomb ticking, and they're going to desperately need more food resources.
And more women.
Yeah. No limit. Anyway, you all know that Tahoe is the 11th deepest lake in the world, and it's gaining heat as a further evidence of global warming. I'm going to speed up a bit now, since a good deal of this has been repeated by Dr. Schlotto with some of his talks. This is work that one of my early graduate student postdocs did years ago, Bob Coates in Berkeley, a Berkeley Forestry student who came and did his PhD on one of our Tahoe streams, and published this paper showing that the whole lake temperature is rising. What I mentioned earlier too was the blanket effect of carbon dioxide, and showing that the back radiation of heat into the atmosphere is where the heat is accumulating on the globe through the greenhouse effect, whereas there's just a huge amount of variation in the maximum daily temperatures at Tahoe City. Biwa is also warming, and you can see that it's, particularly since about 1950, it's actually gone up. Years ago, in my early adventures at Tahoe in the 60s and 70s, Tahoe was actually getting cooler. And if it had continued, Tahoe would have frozen. It got to within a half a degree, the water column, of hitting 4 degrees. And if it hit 4 degrees, then any additional cooling would form ice. Brief history, you're all aware of the Comstock mining. They simply butchered the basin in terms of clear cutting. Then we had the crayfish introduction, which probably was a good introduction. They got an auto route around the lake, the end of the famous drought when John Steinbeck came here. How many of you know what John Steinbeck said? I haven't told you. Know the name of his first book. It's a book you've probably never heard of, and I really don't recommend it. It certainly didn't give the promise that he later showed. It was entitled Cup of Gold. And a really weird story. I got about 8 pages into it. But then he went on to do the Grapes of Wrath and Cannery Row and so on. And he actually wrecked he worked at the old hatchery building and wrecked the boss's car. That may have been why he got fired. And went on to do greater things. The Kokanee were introduced, Squaw Valley for the Olympics, the Tahoe Keys project, which never would have been approved today because people just didn't recognize how important wetlands are for filtering out sediment and nutrients. And then Mysis relicta, the opossum shrimp, was introduced, and we began to get the sewage exported in the very late 60s. And the cladocerans, the tiny little zooplankers that were dominant in the lake, were actually eaten up by the Mysis relicta, and we have a lot of trouble finding cladocerans in the lake anymore, although they may gradually come back with eutrophication. Here's what Glenbrook looked like in 1860, and by 1980, a really interesting book by some, I should have their reference on there, on historical photographs of the Tahoe Basin. And you can see the forest came back. This is exactly the same picture, but they came back with a very dense stand of white fir. And so they stress the water supply in the basin, 1. 2, they don't have enough water during drought periods to produce enough sap to fight off the bark beetles, and we have areas where 70% of the white fir in the basin are dead or dying, which creates a major fire danger, which you hear a lot about. And of course, Heavenly Valley didn't look so heavenly during its erosional stages. And the road network was roughly applied with lots of sediment yield. And fine sediments, of course, are part of the loss of transparency. And Dr. Schlotto has been evidencing that impact over the last decade. This is a shot taken by Emery Kristoff. Emery Kristoff was the photographer of the Titanic, and we got him out here, and he did a lot of underwater footage with a still camera of our small ROV, remote operated underwater vehicle. And that showed since 1942, I think, when the Tahoe was scuttled up Dead Man's Point. That's the sediment that's accumulated. But notice this clean water, how it hasn't impacted the porcelain or the faucets. And of course the wood's in great shape because we don't have marine wood borers here. My student Haber at DRI did the first paleolimnology on Tahoe, indicating the erosion rates and the fact that the bottom of Tahoe is mercifully covered with an aerated, oxygenated layer that keeps the iron in the ferric form. And if this reduced iron below ever gets up to the surface due to the depletion of oxygen in the overlying water, then we'll have internal loading. Nutrients will come back out of the sediments into the overlying water, and we probably will have lost the battle to keep Tahoe blue. The historic period during the Comstock mining, tremendous erosion rate, 450 milligrams of sediment were falling out on each square meter of bottom. Then, when the mills shut down, the vegetation, particularly the brush and the white fir, began to take over. It dropped to less than a quarter of the 450 milligrams. And then in the post-war period following World War II, when Tahoe was really discovered and development started, it jumped to 3 times the level before of sedimentation. And we're hoping now, through a lot of efforts by TERPA, by the Tahoe Conservancy, and by our research group, to reduce this sediment impact. And when sediment comes in, it brings phosphorus into the system. And as I mentioned, Tahoe has changed over a 50-year period from a nitrogen-limited aquatic system to a highly phosphorus-sensitive one. So controlling dust and sediment input is really important now. Jim Elser, one of our best-known students who's worked a lot on phosphorus, got the Evelyn Hutchinson Award in 2012. Been working in the far tip of not Brazil, Argentina, near Bariloche. And he's shown the importance of atmospheric deposition in shifting limitation in Norway, Colorado, and Sweden from nitrogen-limited systems to phosphorus-sensitive systems. He feels actually that phosphorus is going to be the ultimate nutrient limiting factor for agriculture, since there's a limited supply of it, and guano isn't producing enough to compensate for it. We're looking right offshore here at the incline canyon. I made a dive to 995 feet in the Pioneer 1, right about here, and I wanted to go 5 feet deeper. I had my turtleneck on and cap to kind of look like Cousteau, the best I could, and
I was on a hydrophone where no humans ever been before, something like that.
I was trying to get the roughneck who'd come up from Texas with this device that had been used offshore in the Gulf for Kenny oil rigs. And I said, come on, go over 5 feet so I can be at 1,000 feet. And he really was resistant. And I kind of leaned on him. And finally he lifts up the submersible, drifts over 5 feet to 1,000 feet so I can make this earth-shaking announcement. Like stepping out on the moon, I thought. It's for aquatic ecology. And then it got rough topside, and the LeConte was beginning to really rock, and our crew was getting seasick, and so they ordered us to return to the surface before we could come all the way up the canyon, which is what I wanted to do. And we're coming up through these bubbles, and the roughneck turned to me and he said, you know, Dr. Golden, this submersible's never been over 250 feet. And then I began to scream. It was pretty exciting. Anyway, some of you know that the geology of the basin, which has been under investigation by Kent, formerly at Scripps and now at the University of Nevada, Reno. We have these major faults. Tahoe is a graben fault lake resulting from the uplift along its sides or the depression of the basin. And it's kind of serious when you consider that the incline fault is right about where we are. And, the next fault, the West Tahoe fault, which was the main fault creating the basin, and I think you're all aware that Tacoma era slid into the lake, creating a tsunami which some people have estimated to have been 300 feet in height, which would have cleaned the basin out of any early residents. Fortunately, it happened about 2 to 3 million years ago. And then we have the state line fault, and that's another area that, like the Tahoe, could slide into the lake. So life on this globe is uncertain at best. But fortunately, long time periods tend to separate these events. That state line fault, by the way, had a displacement of 21 meters. That is, getting close to 100 feet. And it's happened about 50,000 years ago. And we hope things have stabilized since. The Polk Marsh, of course, was a U.S. Forest Service land, and they allowed it to be dug up and created, of course, the well-known Tahoe Keys. In fact, we had the first real phytoplankton bloom offshore here, which really turned this whole section green for a while when they began to run the water through this old peat, or sphagnum moss, which began to oxidize and release lots of nutrients. This is a shot I took from the air. Bob Richards was flying with me that trip, and I had a former crop duster student who crashed, and was a paraplegic, but he could fly completely with his hands and very well. And we had a super cub that would go up to 17,000 feet. And so we got over and did some shots of the lake. Well, this is what it looked like in 1967. And keep in mind that the Polk Marsh over here is still here. I've been trying to get the Corps of Engineers to put the Truckee River back into that, to regain some of the filtering capacity we lost. And 20 years later, in 1987, most of the keys was built out, and there's been some expansion left, and a little bit of the Polk Marsh still exists over to the west, and of course Cove East is still there, and I'm hoping we're going to get this channelized upper Truckee River back into Cove East. They gave up running it through the Keys, but in the meantime, of course, the Keys has developed water problems like there are so many in the world. This is Kungi in China, and they decided that they'd try to get rid of the pollution in the bottom of the lake by digging it up. And of course, they just released 1,000 years of organic pollution by trying to dig into the bottom. Things buried and then one dug up again. This turned out to be kind of a disaster. The water was actually black with hydrogen sulfide, and you could barely breathe crossing it. And of course, in the Keys, we have the Eurasian milfoil, which has now taken root in many locations around the lake. Somebody dumped an aquarium in, lots of aquarium over the years. So we have largemouth bass and bluegills and green sunfish and catfish in the Keys, which are hoping that Tahoe is going to get warmer so they can expand their invasion of the lake. This shows the fact that very, very few things are native to the lake. The cutthroat trout disappeared with the weir. They made their spectacular growth in Pyramid Lake and then swam up to Tahoe to spawn in the tributaries. There was actually quite a commercial fishery for them at one time. The crayfish were introduced, and there's now a commercial cray fishery in Nevada for them. They're hoping to expand that to California. The kokanee were introduced for the good fishery, and of course the lake trout have been the main fishery for the lake for quite a few years. And a limnologist holiday was, I got up at 4 o'clock this morning and went fishing with Mickey Daniels. So we caught 2 lake trout, which we're going to eat tomorrow. So we've got bass and water milfoil, and we've lost most of the daphnia over the years. Primary productivity, nutrient limitation, and water clarity closely linked. People didn't believe the lake was changing until it began to develop this slippery zone around the shore of paraphyton. And when that bleaches in the spring, turns white, and then comes up as a noxious output in the Tahoe boat works, or some of you I'm sure have seen it along the shore in the spring. The relationship between the depth of mixing with, which has been verified over and over again by Clado, we demonstrated the early 90s by simply plotting the depth of mixing versus the primary productivity. Depth of mixing, the deeper it mixes, the higher the productivity. You see these peaks. It doesn't take a rocket scientist to see that this accounts for most of the variance. So as nutrients drop down through the water column and an algal cell decomposes, releasing its nitrogen and phosphorus, you get an increase in this in the deep water. And when the lake mixes, which only occurs about every 4th year, the nutrients are brought out. So during drought years, the lake is clearer because it just isn't getting as many nutrients as it would if there's a complete mix. And if we just compare nitrogen limitation from 1967 to 1981 with 1982 to 1991, these are what are called bioassay experiments, where the response to phosphorus has gone way, way up since the earlier period, simply because phosphorus is now the limiting factor for growth. So again, controlling sediments and dust getting into the lake has got to be a major element. And this is the average of 58 different experiments for nitrate and 50 experiments for phosphorus, all combined. Sort of meta-analysis. The danger of using short-term data. You notice the transparency here from 1967 to 2002 improved appreciably. Somebody went to Washington and said Goldman solved the problems of Tahoe. Let's cut off the Burton Santini funding. Problem's been solved. Look, the lake's getting clearer. Well, this is the importance of long-term ecological data, and Tahoe and Castle Lake have the best data sets west of the Mississippi, and certainly probably the best subalpine lake data of any place in the world now. And if you look at this, you can see these short runs of improved transparency that have occurred, and those are drought periods. The lake isn't getting a late winter storm to mix it all the way to the bottom. One of the developments from Southern California with El Cajon was nutrient remover through artificial wetlands. We put one of these in at El Cajon, and you can see the inflow versus the wetland effluent. You just clean an awful lot of stuff out. And the example at the Y at Tahoe City again shows the white or the inflow, the blue are halfway through the little wetland, and the red are the outflow. Again, just pure gravity and plants can knock down the nutrient level. Getting the politicians involved, I'm not going to tell any Clinton jokes, but definitely the most charismatic individual I ever had on the boat, and actually Al Gore wasn't a bit wooden, so it was a big deal since there wasn't any competing activity at the time. The future, of course, are our children. Heather has already told you about the annual Children's Day, and those of you who remember the remarkable color photography of J.T. Ravizet can appreciate that as this picture fades out. Now I'm going to end on a light note with all the reports of Tahoe monsters. Now I can get a crowd like this in for a talk on Tahoe, but if I give a talk on USOs, unidentified swimming objects, I can get 1,000 in every time. This, of course, is the support of Turk researchers that many of them came on from the Tahoe Research Group, have continued. Ann Liston is here, I noticed, in the back. A lot of real stalwarts that have stayed with the operation. I don't think there's any research group in the country that has maintained such a long tenureship of good scientists and technicians as the Turk group. The building we built here in Nevada brought Nevada and California together to face lake problems, and Castle Lake is now in its 54th year of data analysis, and USOs. I just want to make one thing clear. That's the original picture of the USO at Loch Ness. And that actually is an elephant snorkeling across the river. And of course, even Science magazine got interested in it. And Ulysses Aldrovandi did a compendium of fish and whales published after his death. And sort of at the end of the Dark Ages in 1612, it's considered an excellent example of the explosion of scientific interest in natural history. With climate change, there's been a certain turn back in that. It kind of reminds me of the arguments over the monkeys. Anyway, these are the imagined monsters that are in this book. My dad bought a copy of it after World War I in Paris that I still have. 400 pages of 400 woodcuts in it, which are amazing. And a lot of them are pretty accurate, but many of them are very fanciful. And Nancy and I were invited by Robert Raines, the great Tessie hunter, to go over to Loch Ness with an enormous $1 million submersible to look for, he said, the remains of Tessie, because Tessie had not been, Nessie had not been seen for a number of years. And that's the great-grandchild of that little submersible we showed in the Tahoe steamer, made in Fallon. And Nancy found Tessie. And we drank a lot of good Scotch whiskey there. And this actually is a picture from the Aldrovandi book that could be Asapenser tahoensis, the surgeon, which might be what people have seen. If a surgeon actually was released accidentally with one of the many fish stockies of Lake Tahoe, completely possible. And today I asked Mickey Daniels again about it, and he said, well, as far as he knew, that somebody had actually claimed they caught a sturgeon in Tahoe. Well, I'd like to see that confirmed. That would explain Tahoe Nessie. And of course, people are afraid of that monster. They've made extra provisions to keep them on shore, keep them from getting to shore. And thanks for your attention.